Welcome Calculus AB. This is lesson 2.5, derivative rules, tangent lines, and rate of change. Let's begin. So we're going to start doing some different calculus here. This is stuff that's not review anymore, and it's brand new to calculus. And one of the concepts of calculus, we learned this idea of a derivative. So a derivative is the slope of a tangent line to a function. So you see that GIF over there on the side. Basically, at any point in the graph, we want to be able to say, what's the slope of the graph? And let's look at this one that I'm playing with right here. You can see that the slope, if you follow the graph from left to right, it's going down. So if I were to draw a tangent line, it'd be like a negative line doing something like this. It's a rough idea. But when you get to the very bottom right here, our tangent line is actually going to be a straight line across. It's the idea with the tangent line is it hits the graph once, and it's just kind of matching the slope. And then when you come back up, going up like this, expect your tangent lines to start becoming positive again, the slope of those tangent lines. And then when we get to the top again over here, it's leveling off, and then it'll hit 0 again. So you have a horizontal line. Then we'll hit a negative tangent line down here, and it hits 0, then it goes up. So this is just an idea. And you can see with that animation, it might explain a little better. That slope of that tangent line changes as you go around the function. And every time you kind of go around one of those curves, it changes if it's positive or negative. And then sometimes it's really, really steep, so really, really positive, or really, really negative, like right now, where it's very negative tangent line. And then you see it's inching back up. So what's cool is we want to find that slope of that tangent line. And we'll go over the definitions of this eventually, but just want to introduce this to you. So let's take an equation if I had x squared right here. So this shows the shape of a parabola. If you were to do tangent lines, notice over here on the left side of your parabola, you'd have a very negative tangent line. I'm just going to start drawing tangent lines at certain points. So I'm going to do it on a pen. See if we can draw straight lines. So if you want to do a tangent line right there, your slope would be a line like this. And then down here, you'd get a slope of a line that's like this. Notice it gets less, it's really, really steep over here, but it's less steep as you get close to the 0 point. The slope here is not as negative as before. And then when you get to this point, it's going to be a straight across line. And then after that, we start getting positive. And then over here, you get even more positive. And even here, even more positive. So what we can actually do with this is we can see that there's tangent lines. We actually want to create another function that maps not just where our y value is the graph. This is going to map out what the slope is at any point, or the derivative is at any point. Notice over here that our derivatives are very negative, and then over here it's very positive. So if you actually plotted this out in brown, we'd start off very negative over here, and then the slope would hit 0, and then it starts getting positive. So if you found the derivative at every point, and I made a graph of the slope at every one of those points, we'd actually form a line that looks like this, just mapping out the slopes. Well, that line is a function, and the equation for that function is y equals 2x. It's a linear function with the y-intercept at 0, which is kind of neat. So we know that we can make a function, but we also have some rules, you don't have to just draw a graph of it. We have some rules to come up with the function for the derivative. And we're going to start with some of those rules today. So, and before we get into this, let's talk about notation a little bit. So again, derivative is the slope of a tangent line, and we pick a certain x value, so slope at that point. We have a few different notations. So we might say derivative f prime of x. So you'll see it written as f prime of x. So instead of saying f of x, that prime means derivative. We might also say y prime. So instead of just saying y as a function, y prime means the derivative. You all see this notation dy dx a lot. This is derivative of the function y with respect to x. This notation right here is kind of combining this one and this one. So you might see this. Sometimes derivative, we said it's a slope of a tangent line. So slope is m when we write an equation of a line. So we might say m. This notation, don't worry about it for now. We skip this for now, but we're going to come back to it a little bit later. But it's kind of the limit definition of derivatives. Okay, write this down. Power rule. So this is one of the rules that you can use to find a derivative function. So the derivative of some x to the n power, where n is any integer, is n times x minus 1. And so let's do some examples. So if I had f of x was x to the fourth, f prime of x would be, what you do is you take that exponent out as a coefficient, so 4, and then subtract 1 from that exponent, so x cubed. Now take the equation y equals x. This is like x to the 1 power. So y prime of x is take out the 1 times x to the 0 power. You subtract 1. Well, anything to the 0 power is 1. So really our answer is 1 times 1, or just 1. So the derivative of just an x is 1. All right. Let's a constant rule. So if you derive any constant, the derivative of any constant is 0. So if I said y equals 5, which is just a horizontal line, y prime would be 0. Y equals negative 1, y prime would be 0. If I said y equals 0, y prime is 0. That all works. Now, so we call this scalar multiple, but the idea is that we just did power rule. What if there was like a coefficient in front of that function? Well, all you do is when you derive it, you just keep multiplying by that coefficient. And so let's do some examples here. So, and then we also have this idea of the sum rule. So if you have two different functions, like being connected by pluses or minuses, you just derive each term separately. So this just means derive each term separately. So let's take number 2. This is where I have two different terms, this term and this term. Well, I'm going to derive x to the negative 2/3. Now, following the power rule, you take the negative 2/3 out as a coefficient, times x, if you subtract 1, so negative 2/3 minus 1, which is negative 2/3 minus 3/3, you are going to get negative 5/3. So negative 2/3 times x to the negative 5/3, and derivative of 3 is plus 0. So I can just write this as negative 2x to the negative 5/3 over 3 is a fine answer. Now try this one. This is where I have a coefficient. So just find the derivative of the x cubed part, and then you multiply it by 4 at the end. So it looks like this. Y prime equals 4 times, take that 3 out, x to the squared. So this is going to be 12x squared. That's it. All right. Now there's going to be a bunch of practice. We're going to save this for class. That's it for today.